So I'm going to try to give you a little bit of help with this first lab here. This is just the first part of the video. I'll try to make another video on some more of the calculations, but this is just trying to get the volume of your empty pycnometer. So one of the first things you looked at was the mass of the pycnometer. And of course there's uncertainty on that, so I'm going to use this lowercase d here. D standing for delta, which often is used for uncertainty stuff. So I'm just going to type d mass of the pycnometer, and there are two types of uncertainties. So the uncertainty I care about, actually I need to put them both in there, so let's put this first one in for ABS for absolute. I'll just resize that column, and of course I should probably put in a column for the percent as well in case I need that for anything. Oops. Just to label it up. So I'll put a percentage sign in there. Okay, so now I've got this set. Let's say I'm only going to put the first trial in at first here. So let's say I weighed the empty pycnometer and it was, I don't know, let's make up a number, 10.2 grams. That's what I got in my experiment. I use the electronic balance for this, which has a absolute uncertainty of 0.01 grams. So I could just type in 0.01. What I think is going to be a little bit better though, and I'll show you a case in a little bit, I'm actually going to type in equals 0.01 grams to put that in. And then to figure out the percentage, I can do that as a formula equals, well, whatever percent of this, the absolute is of the actual. So I will do that times by 100 to put it into a percentage. Better resize that column. Okay, so I've got my first value put in. And the second thing I recorded in the experiment was the mass of the pycnometer plus water. And I don't know, again, this would be an experimental number. Let's just say that I got 36.2. And I need to put my uncertainties in as well. I'll just put it in like this. I need to make a column for the percentage uncertainty. And we can fill those in. Now, remember over here I said put it as equals 0.01. I'm just going to show you, because we're going to do some fill down stuff here in a second. I'm going to show you this column. I'm just going to type in the 0.01 so you can see what happens when we get to the fill down. So it doesn't mean anything right now. This one's going to be the percentage just like before. It's, what percent is the absolute of the actual value. Put it into percent with 100. Okay, now it's time for the first calculation. The first thing I need to calculate is what's the mass of water in that pycnometer. Well, that's a pretty simple calculation, but the spreadsheet keeps everything in my uncertainties nice and organized. So it's really just this value here, the pycnometer plus the water, and I just subtract off the mass of the empty pycnometer. I'm going to put that in as a formula. So it's that number minus this number here. And I got the mass of water. Of course, I need to put in my uncertainties as well to make sure I keep those things set. Resize this column, and let's try d mass water percent. Alright, so to get this 26, I actually did some subtraction. When you're subtracting numbers, and now I need the uncertainty on the mass of water, I have to add the absolute uncertainties of the two numbers that I used. So I'm going to put this in as a formula. It equals the absolute uncertainty on the 36.2 plus the absolute uncertainty on the 10.2. And so the mass of water in there was 26 grams plus or minus 0.02. And I can get the percentage just like we've done before. Okay, so we've got that set. I got one more calculation to do here, and that's of course to get the volume of the water. And I will set up columns for the uncertainty in the water as well. Okay, so the volume of the water requires that density that you use. So I'm just going to type this in. I don't know what the density of water was on the day that you did the experiment. That's what you want to write down. But I'm just going to say, oh, I looked it up on the day I did it, and this was the density of water, which was the same for all of my trials. So I'm just going to type that in right here. In fact, maybe I should have put that a little bit lower, so maybe I'll bring it down. Okay, so to get this volume, I need to take the mass of the water divided by the density. So I'm going to put equals. I'm going to click on my mass button here, press divided, and now I'm going to put in the density. Before I hit enter, I'm going to do some fill downs in a little bit. And when I fill down, I would be running into a problem. I want all of my calculations to use this one density value since they all had the same density. But fill down makes it want to reference the next cell below. So right now you see this cell is saying, oh, it's take G2 divided by C7. But when I fill down, this next one below it's going to say take G3 divided by C8. Well, I don't want to divide it by C8. I want to still divide it by C7. I kind of want to lock that cell in place. So I need to put some dollar signs around the C and the 7. I could manually type those in, or I can press the F4 key. I'm going to do that right now. And now notice that those dollar signs are in there on the C and the 7. And I'll hit enter. Okay, so to get this value, I actually did some division. So I'm not going to be able to get the absolute uncertainty right away. I can do the percentage though. The percent, when we do multiplication or division, remember we have to add the percentage uncertainties of the numbers we used. So this is going to equal, well, the percentage uncertainty on the mass, because I use the mass, and it's also going to equal the percentage uncertainty on this density. But we're going to treat it like that density is very, very well researched. A lot of people have done that over the years. We're going to act like it's about 0% error on that. So I'm just going to type in a +0 in here as a holder. You, of course, don't have to do that. It can just be it's going to be the same as the percentage uncertainty on the mass. So I hit enter and I get that. And now I can back calculate to figure out what this absolute volume is. Absolute uncertainty in the volume is. And that's going to equal, well, it's going to be this, but I got to turn it back into a decimal, so I'll divide it by 100. And then I multiply it by the actual volume. Alright, so now I've got the volume of water, which, since the whole pycnometer was filled with water, that's really the volume of the pycnometer, and I got it for one trial. So let me go back here and I'll enter in some other values for my second and third trials. Now let's see, what do we got here? Let's just say I got one experiment where I got 10.3 and 10.1. And for this one, let's say I got 36.5 and 36.1. Okay, we'll do some fill downs. I could actually fill down the whole thing here. Well, it would overwrite this, so we have to be careful. I'm going to fill down these. And when I do that, notice I wanted to keep the uncertainty on the scale for the same for each one. Remember, I did equals 0.01 in this case. I'm going to fill down the rest of these. Let me move this over a little bit. Okay, I'll set that up and I'm going to fill it down. And everything worked well, but you see that my percentages are getting pretty high here. And then I look at this column and say, well, wait a minute. This is correct. The absolute uncertainty on this reading, since it was a scale reading, is 0.01. But this is not 1.01. It should be the same numbers. Remember, this is one where I just typed in 0.01. This one I typed in equals 0.01. In the fill down, it keeps them the same. This one, it changes. So here's what I could do is I could actually make this equals 0.01. And I can fill that down and it calculates that, changes all my numbers, and now I've got my pycnometer set to go. There's maybe one last thing that you want to do and figure out what the volume of the pycnometer is. Well, we might want an average value of these sorts of things. So I'm going to type in equals average, and I have to use an open parenthesis above the 9. I'm just going to left click and hold to highlight the numbers I want to take the average of. And here you can actually close the parenthesis, or you can just hit enter, and it gave me an average. And now to get the average on my uncertainties, I can do that as well. I can actually do that in a fill down. And now I've got all the calculations I need for part 1 with the the volume of the empty pycnometer. This spreadsheet here is good for what I need to do. I've got my calculation set, but notice it's pretty sloppy. I mean, it's good for me, but someone reading this wouldn't know what D mass P abs mean. No one would like to see this with all these decimal places here, or what D stands for. A lot of people like to just cut and paste this, put it right into Word, and turn it in for a report, and that's not good enough. We still have to clean it up a little bit, but there are some tricks we can do for that and put it in to make it look nice and neat. But anyway, at least the calculations are done, and this will save us some time with some of those tedious, repetitive calculations. Maybe this lab, it took you a little bit more time to get used to this, but as you use Excel more and more, you could have probably done what I just did here in about 2 to 3 minutes.